today we are going to see the problems on gamma distribution. Okay, so already we saw that last class how to find the statistical measures of gamma distribution like mean, variance and standard deviations, how to calculate. So we saw last class. Now we are going to see the problems on gamma distributions. Okay, so suppose that telephone calls arriving at a particular switchboard follow a Poisson process with an average of 5 calls per minute. What is the probability that up to a minute will elapse until 2 calls have come into the switchboard? Okay, it means that, so here it is first what is the information they give about telephone calls. So telephone calls arriving at a particular switchboard. So already we saw that this type of problem in Poisson distributions. That only here they are saying. So coming into a telephone calls or coming into a switchboard, it process follows a Poisson process. And on average, how they are what they are saying 5 calls per minute. Okay, what is the probability that? So it means what we need to calculate. We need to find the probability up to a minute will elapse until 2 calls, okay, have come into the switchboard. So up to a minute, it means that how much time it takes for coming 1 minute or less than 1 minute, up to a minute. Okay, so up to a minute in the sense, so 1 minute, so 1 minute less than 1 or equal to 1, so up to minute we can say that will elapse until 2 calls have come into a switchboard. Okay, so this is the information they give. By taking this information, we need to find probability of x less than 1. So less than 1 or less than or equal to 1. Okay, why? Because we are using continuous one, there it is having integrations means 1 to infinity. Okay, so that one here they give. So here they mention 5 calls per minute. Here it is for applying this gamma distribution. What are the parameters we require? Alpha and beta. So these are the parameters we require. Okay, so alpha we need to know that and beta we need to know that. So here already they mentioned alpha is equal to how much, that is 2 calls, and beta is nothing but we need to calculate 1 call for 5 minutes. Okay, so that is 5 calls per minute. So that is simply we are writing as 1 by 5 minutes. So it means per 1 minute for 5 calls we are getting that. Okay, so here it is. So that only simply we wrote here the Poisson process applies with time until 2 Poisson events following a gamma distribution with beta is equal to 1 by 5 and alpha is equal to 2. So here it is, alpha is equal to 2 calls and beta is equal 1 call per minute. So here it is, they give 5 calls per minute. Okay, so it means for 1 minute how many it takes? 1 by 5th call. Okay, so that is simply we wrote, and denote x the time in minutes that transfers before 2 calls come. So x we are defining as, so before 2 minutes how much it takes. Okay, time. Okay, so the required probability is given by, so what is the formula we are using for Poisson gamma distribution? Here it is. So p of or f of x is equal, f of x is equal 1 by beta power alpha gamma alpha. So 1 by beta power alpha gamma alpha x power alpha minus 1. Okay, so x power alpha minus 1 and e power minus x by beta. So this is the function we are using for x greater than 0. So x greater than 0, this one we are using, and if it is 0 otherwise, so rest of the cases the value become 0. So that one we are using, right? So here it is, we are calculating here p of x less than 1 and are equal to 1. So here it is, simply we can say that one, so up to 0 to infinity. Why? Because here it is what we are saying, x greater than 0 only this function is valid. Rest of the cases that is 0. Okay, actually what we'll say that integral minus infinity to infinity, we'll say that. So here it is up to 1 we are calculating now, so minus infinity to 1. But as per the definition of gamma distribution, how can we split this one? Integral minus infinity to 0 and next 0 to 1. So minus infinity to 0 plus 0 to 1. Okay, so in this case the function is 0 and in this case we know that the function. Okay, So that's why we are writing here 1 by beta power alpha gamma alpha x power alpha minus 1 e power minus x by beta. Here it is alpha is equal to 2, already we know that, and beta is equal 1 by 5. Simply we are calculating that 0 to 1. Here it is 1 by beta square. So why? Because alpha is equal to 2, and next gamma alpha is nothing but 2, and next x power alpha minus 1, that is nothing but 2 minus 1, and next e power minus x by beta. So minus x by beta is nothing but how much? Here it is 1 by 5 dx. So from this simply what we are getting, so beta is nothing but 1 by 5 whole square, right? So here we write 1 by 5 whole square. So 1 by 5 whole square is nothing but 1 by 25. That one goes to numerator. Simply what we'll get, 25 by gamma 2, and next x power 2 minus 1 is nothing but x, and next this is simply we'll get it as e power minus 5x. So this is the one. So e power minus 5x dx. Why using this gamma 2? So already we know the formula for this. We are using the properties of gamma function. Simply which formula we are using gamma n plus 1 is equal to n into gamma n. So this is the formula we are using. In the same way, here it is 2 we have, so gamma 2 is equal, simply what we can write, gamma 1 plus 1, right? So we can write it as gamma 1 plus 1. If you compare these two, in place of n what we have, 1 we have, suppose that 1 into gamma 1. So we already know the value of gamma 1. So gamma 1 value is 1. It means simply what we got it, gamma 2 is equal to how much? 1. So this value is 1, and 25 is a constant. So further simply what we can write, 25 integral 0 to 1 x into e power minus 5x dx. So x into e power minus 5x dx. So this is the remaining one. Now we are going to calculate this. So 25 is a constant, we don't change anything in that, so we'll write as this. And next x e power minus 5x. So this one we can solve in two ways. One of the way is nothing but by substitution method. It means by taking some assumption, put 5x is equal to t, and then we can calculate. Or by using UV formula we can calculate this one, integral UV. This one we already applied in continuous random variables in first unit what we saw. So which formula we are using that? So here it is, we can see that. So here it is, we got that one on. See here, 25 x into e power minus 5x dx. So which formula we are going to apply? Integral UV dx. So this is the formula we are using, right? So UV dx is equal, simply what we can write, u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus and so on. So this is the formula we are using. Here what we have to choose u. U is nothing but terminating one. So after applying n derivatives, what will terminate? That one simply we can choose u, and v is nothing but non-terminating one functions. Generally what we'll say that is we use for islet. So this is the formula we use for generally. So islet is nothing but, I is nothing but inverse, L is nothing but logarithmic, and A is nothing but algebraic, and T represents trigonometric, and E represents exponential. So based on this order we have to choose U and V. If you don't know that, simply what we are saying, U is, we can treat it as terminating one. So terminating in the sense, whatever the function you are choosing, after applying derivatives, if you are getting 0, then we can apply, you can choose as u, and we can choose as non-terminating one. It means it doesn't approaches to 0. So here it is, if you see that, if you are choosing u is equal to x, so u is equal to x and v is equal to e power minus 5x. Okay, so if we are taking islet also same thing, as to see that algebraic is the first it will come. So for that we are choosing x, and next exponential we are getting as next term. So u is equal to x and v is equal e power minus 5x. Now we are going to apply derivatives for this. So if you apply derivatives, see that u dash is nothing but The derivative of x is here 1. And next again if you apply derivative for this, so one derivative is nothing but what will get 0. Okay, so it means it is terminating 1. And next v1, so v1 is nothing but one time integration, so e power minus 5x integration is we will get it as e power minus 5x by minus 5. So this is the formula. And again v2 is nothing but v2 represents 2 times integration of this one. So one time is already we calculated. Again if we calculate integration for that, we'll get same as this. So e power minus 5x by minus 5, and again we are applying integration means minus 5. It means simply what we'll get, e power minus 5x by minus 5 into minus 5 is nothing but 25. So 25. So of course no need to calculate v2 also. Why? Because up to this we are getting. So this is obviously 0. Now we can substitute those things here. So x into e power minus 5x dx. So e power minus 5x dx. So this is equal to simply what we can write. So u is nothing but what we chosen, x, and v is nothing but v1 is nothing but one time integration, that is nothing but e power minus 5x by minus 5. So one time integration. Next minus u dash is nothing but what we got it there 1, and b2 is nothing but what we got it here, e power minus 5x by 25. So e power minus 5x by 25. So this is the one. Okay, so this one we got it. Now next, if you extend this formula, u double dash is nothing but what we are getting here. So u double dash is nothing but 0. So here it onwards, it terminates. So only this one we got it. And we are calculating here between the limits 0 to 1. So for that, 0 to 1. So here you need to know that first we need to substitute in place of x as 1 upper limit. And what we get here it is 1 into e power minus 5 by minus 5. So this is only we get if you substitute upper limit. Next minus e power minus 5 by 25. Next 0 into anything 0. So this term, complete term becomes 0. And next when you are substituting lower limit, the sign will change. E power 0 is nothing but 1. So 1 by 25. So this one we got it. And next if you take the LCM for this entire one, so 25 is the LCM. And next how many times it goes? 5 times. So minus 5 e power minus 5. Next this is only one time, so e power minus 5 plus 1. It means simply what we got it here, 1 by 25 into, so this is simply what we got it here, 1 minus 5 1, so that is nothing but 6 e power minus 5. 6 e power minus 5. So by using calculus we can calculate this value. So this is the required one. Nothing new we are doing, just we need to understand the problem clearly. After getting that, simply we need to apply integration. Okay, so that is the only thing we are learning here. Okay, so how to apply integration, that one you should be perfect. So here most of the problems we use this formula only. What is that formula? Integral uv dx. Bernoulli's rule will Bernoulli's formula will say this one, uv1 minus u dash v2 plus u double dash. Or simply you can take the same another one, you can take assumption 5x is equal to t and differentiating on both sides, you get it as pi dx is equal to dt. So pi dx is equal dt, and then dx is equal to what we'll get, 1 by 5. So 1 by 5 dt, and obviously this is definite integration. We need to take the assumptions for this also. If you are taking x is equal to 0 here, so x is equal to 0 when t is equal to, so when x is equal to 0, t is equal to 0. Why? Because 5 into 0 is 0. Next when x is equal to, here it is what we have 1, and then t is equal to what we'll get, here it is having 5 into 1 5. It means we are converting the entire terms into in terms of t. So simply what we can write here it is 25. Okay, so here we forgot it here, 25 is there, so 25 25 also, so it cancel, so that is here you will get it as 1. Okay, so this is not, so it means the final answer is 1 minus 6 e power minus 5. Okay, So here it is 25. You can see that integral 0 to 1. When x varies from 0 to 1, t varies from 0 to 5. Right? And next here it is x. So x is equal to means simply what we can write t by 5. T by 5. And next here it is simply what we have e power minus 5x. So e power minus t. And dx is nothing but simply what we'll get 1 by 5 dt. So 1 by 5 dt. So here it is 5 into 5 is nothing but 25. These two will cancel. So remaining what we have 0 to 5 t e power minus t dt. So t e power minus t dt. So this is the one. Of course, again you need to apply the same thing, right? Same formula you need to apply. So if you apply that formula, so what we'll get for this one? So first we'll get it as t, and e power minus t integration is minus e power minus t, and next minus the derivative of t is nothing but 1, and integration of that one is e power minus t. And between the limits here it is 0 to 5. 0 to 5. And then if you substitute the limits, what will get? Minus 5 e power minus 5, and next minus, here it is having, so minus e power minus 5, and next if you substitute lower limit, 0 into anything 0, and when you are substituting lower limit the sign will change, minus become plus, e power 0 is nothing but 1. So simply minus 5 minus 1 is nothing but minus 6 e power minus 5 plus 1. So finally what we got it here, 1 minus 6 e power minus 5. If you see here, same we got it or not, 1 minus 6 e power minus 5. So either you can follow this process or this process. So this is direct formula we are using, and this is for substitution assumption method. So just like us, we have to take some, we are converting into variable some another variable, and we are reducing that. After that we are applying integration. Okay, so either you can follow this or this one. Why? Because most of the problems will get the same thing. Okay, product of two functions, here you will get it, one is algebraic and exponential. Why? Because we are using a gamma distribution. As per the formula, it consisting of the same exponential and algebraic one. Okay, here the only one important thing is you need to understand the question clearly. If you understood, then you can get easily. See here, 1 minus 6 e power minus 5. So the value is here 0.96. So probability we are finding, don't forget it. So obviously the value lies between 0 to 1. So as usual. Okay, next, here it is, we are saying that, so not only for that, while the origin of the gamma distribution deals in time, so in time we can use that until the occurrence of Poisson events. There are many examples we will use. Gamma distribution is the best distribution comparing to what we learned in previous distributions. Okay, so next, same like that, you can see the question in a biomedical study with rats. So it means already we said not only in general one, so in biomedical industry also we are using these distributions. Normally it's nothing but in statistical inferences we use, and gamma distribution we are using in biomedical industries, we are using that. Okay, so in a biomedical study with rats, so we are discussing the biomedical study about with the rats. A dose response investigation is used to determine the effect of the dose of a toxicant on their survival time. It means what we are saying here, so suppose they are preparing some dose of some injection like that. Okay, so they want to check the toxicant of that dose, how much effectively it is working. Okay, so after giving that, so how many days those rats are surviving is nothing but living. Okay, how many days those rats are living by giving that particular dose of a toxicant in the sense poison. Okay, the toxicant is one that is frequently discharged into the atmosphere from jet fuel for a certain dose of the toxicant. The study determines that the survival time in weeks as a gamma distribution. But saying that gamma distribution, they are saying here, so they are not giving directly the toxicant to the rats. Okay, just they are giving in, they are releasing in atmosphere. Okay, from jet fuel. So by using jet fuel, they are releasing the toxicant in the atmosphere. Okay, Like us, so just if we are preparing any particular medicine, first they're testing on that particular rats or cats, okay, monkeys, like that. So in the same way here also they are doing that, but they are not giving directly the toxicant to rats, just they are releasing the toxicant from jet fuel in atmosphere, okay, by breathing that, okay, how many days that will survive, okay, how many days those rats are living, okay, and that survival time they are measuring in here in weeks, okay, in weeks they are measuring the survival time of rats, okay, after giving the toxicant, and the toxicant also they are releasing in the atmosphere by breathing that, okay, how many days, how many weeks those rats are surviving. So the total one they are defining as a gamma distribution with alpha is equal to 5 and beta is equal 10. And what they asked here, what is the probability that a rat survives no longer than 60 weeks? Okay, so here also simply what we need to calculate, we need to calculate probability. So but what they're asking that the rat survives no longer than 60 weeks, okay, so it means, so more than 60 weeks it doesn't survive, okay, so no longer than 60 weeks is nothing but, so it less than 60 weeks, so how many days it will survive, okay, so that one, that is what are the possibility for that, so that possibility we are going to calculate here, okay. So for that we are defining, let the random variable capital X be the survival time. So why? Because we are going to calculate rat's survival time here. So for that, so let the random variable capital X be the survival time, okay. And the required property is, we already said that there it is gamma distribution. So for that we defining that gamma distribution. So f of x is equal p of x less than or equal to x is equal 1 by beta for alpha, gamma alpha is equal integral x greater than 0 is nothing but simply what we can write, 0 to infinity x power alpha minus 1 e power minus x by beta dx. This is the one we are writing. And here already they mentioned in the problem alpha is equal to 5 and beta is equal 10. So simply we have to substitute in that, and then we are going to calculate that, okay. So simply here it is 1 by beta, already how much they give, 10, and alpha is nothing but 5 they give, so 1 by 10 power 5, gamma alpha is nothing but how much, 5, integral 0 to infinity x power alpha minus 1. So x power alpha is nothing but here 5. So 5 minus 1 and e power minus x by beta. So beta is nothing but 10 and dx as it is. Simply here just we are substituting all these values in the formula and then we are calculating. But here it is, this is generally up to x, but up to what we are calculating here, 60. So for that, in place of infinity up to 60, it means we are splitting the interval as 0 to 60 and 60 to infinity. So we have the function only for up to 60 and rest of the cases that is 0. Now 1 by 10 power. So continuation of that. So here it is what we are using. Simply we are substituting the values. Okay. So in the formula here it is intake 1 by 10 power 5 and gamma alpha. So gamma alpha is nothing but 5, integral 0 to 60, up to 60 we are calculating. So x power alpha minus 1. So alpha is nothing but 5 minus 1 and e power minus x by beta is nothing but 10. So 10 dx. Now we need to calculate this one, 1 by 10 power 5 and gamma 5 here it is. So gamma 5 is nothing but simply what we can use the formula, gamma n plus 1 is equal to n into gamma n. So this is the gamma function property we are using. So we are going to calculate here gamma 5. So gamma 5 is nothing but simply how can I write that one, gamma 4 plus 1. So gamma 4 plus 1 is nothing but, just we can compare these two. So in place of n we have 4. So simply what we can write, 4 into gamma 4. 4 into gamma 4, and then so 4 into gamma 4 also we require. So gamma 4 again what we can write, 3 plus 1. So this is simply we can write 3 plus 1. So for that 4 into, now we can treat it as n is equal 3. So again by taking that formula, simply what we can write, 4 into 3 into gamma 3. And again simply what we can write that one, so this is equal 4 into 3 into, and gamma 3 also, how can I write that one, gamma 2 plus 1. So this is equal 4 into 3 into, and same formula we are using here, 2 into gamma 2. So gamma n plus 1 n into gamma n. So simply how can I write this one? 4 into 3 into 2 into gamma 2 is nothing but simply how can I write that one? 1 plus 1, right? So this is equal, simply we can write 4 into 3 into 2 into 1 into gamma 1, gamma 1. So simply what we can write this one, 4 into 3, 12, 12 into 2, 24, 24 into 1, 24, and gamma 1 value, we know that 1. Okay, so it means if you observe this one, simply what we are getting, gamma 5 is nothing but what we got it here, 4 into 3 into 2 into 1. In the same way, we can write for any value. So gamma 10 is nothing but what we will get here, it is 9 into 8 into 7, 6, 5, 4, 3, 2, 1, like this. Okay, so like this you can get the value. So here it is, gamma 5 is nothing but how much we got it, 24. So simply we can write into 24 integral 0 to 60 x power 4 and e power minus x by 10 dx. So minus x by 10 dx. So this is the one. So again what we got it, if you observe this one, here it is having x power 4 and here it is having e power minus x by 10. Again we have product of two functions, so we can apply UV form. So here we can choose u is nothing but x power 4 and e power minus x by 10, that is nothing but you can choose as v. So directly we can apply that formula what we discussed, UV, or simply assumption, simply what we said,